July 10, 2006. 11:01 p.m. inside the I-90 connector tunnel in Boston, part of the $14.6 billion Big Dig, the Central Artery Tunnel Project, a concrete ceiling panel measuring 20 by 40 feet and weighing 26 tons detached from its epoxy-anchored bolts. It fell directly onto a passing car. Milna Del Val, a passenger in that car, was killed. The driver, Angel Del Val, was critically injured. This was not a sudden, unforeseeable structural rupture. It was the end point of a decision chain that began years earlier, during construction, when warning signs about the very bolts that failed were observed, recorded, and set aside. The panel itself was not some minor cosmetic fixture. At 52,000 pounds, held up by anchor bolts fixed into the tunnel roof with a fast-set epoxy adhesive, it was one of hundreds of similar ceiling tile assemblies lining the connector tunnel. The system depended entirely on the epoxy holding its grip on the bolts, indefinitely, under constant load, in a highway tunnel carrying regular traffic. The National Transportation Safety Board's subsequent investigation would establish the immediate technical cause with precision. The epoxy used could safely sustain only 4,285 pounds of long-term holding capacity per bolt. The actual load imposed by the ceiling assembly was close to 5,000 pounds per bolt. The gap between what the adhesive could hold over time and what it was actually holding was not a rounding error. It was a persistent, calculable shortfall built into the tunnel the day it opened. This script follows that shortfall from its origins in construction-era testing, through the funding and oversight decisions that let it go unaddressed, to the moment it caused a fatal collapse, and through the litigation that followed. The story is not about a single broken bolt. It is about a testing failure in 1999, a monitoring void after 2003, and a chain of institutional actors who each had the opportunity to catch the problem before it became fatal. The warning arrived years before the collapse, during the tunnel's original construction. In 1999, 5 anchor bolts failed during testing. This was not an ambiguous or marginal result. It was a direct, physical demonstration that the epoxy and bolt system, as installed, could not reliably bear the loads intended for it. At that moment, project managers had a clear decision point: expand the testing program, investigate why the bolts failed, and determine whether the failure was isolated or systemic. They declined to pursue further testing. That decision, made in 1999, is the hinge on which the entire subsequent chain of events turns. Whatever combination of confidence, cost pressure, or schedule priority led to that choice, the practical result was that a known failure mode was allowed to remain unresolved inside a highway tunnel destined to carry the public. A Massachusetts Inspector General report later examined how the anchor system had been built in the first place, and the findings describe a process with multiple points of breakdown. The design specifications for the anchor bolts were poor. Contractors were paid to test anchor bolts that had themselves been improperly installed, meaning the testing regime was validating a flawed installation rather than catching it. And there was a lack of consultation with the tunnel's own designers before contractors drilled through steel reinforcement in the tunnel roof to place the anchors. Each of these findings represents a separate checkpoint where engineering judgment should have intervened and did not. Poor specifications meant the anchor system was undersized for its task from the design stage forward. Testing improperly installed bolts meant that even a passing test result could not be trusted as evidence of real-world performance. And drilling through reinforcement steel without consulting the designers meant that decisions with structural consequences were being made in the field, disconnected from the engineering judgment that had produced the tunnel's design in the first place. None of these were secret conditions. They were procedural facts about how the anchor system was built, sitting in the record for anyone conducting a rigorous post-1999 investigation to find. But because the decision in 1999 was to not pursue further testing, none of these deeper installation problems were surfaced or corrected before the tunnel opened to traffic in 2003. The tunnel opened to traffic in 2003. From that point forward, the epoxy anchors did not fail instantly or dramatically. They deformed. Slowly, under sustained load, the epoxy crept, losing its grip on the bolts a fraction at a time, exactly the kind of gradual failure mode that a monitoring program is designed to catch before it becomes catastrophic. No such monitoring program existed. Not from Modern Continental, the contractor that built the tunnel. Not from Bechtel and Parsons Brinckerhoff, the project's designer and manager. Not from the Massachusetts Turnpike Authority, the public body responsible for the tunnel once it opened. Three separate institutional actors, each with a plausible claim to responsibility for the tunnel's ongoing structural health, and none of them implemented a system to track how the epoxy anchors were behaving under years of real-world load. This is the structural gap at the center of the failure, viewed through the lens of institutional responsibility rather than material science. A known 1999 test failure had been set aside without further investigation. A 2003 tunnel opening proceeded without any mechanism to verify, over time, whether the anchor system was holding up as intended. The result was a multi-year window, from 2003 to 2006, during which a slow-motion failure was underway inside a live highway tunnel, invisible to every party that might have caught it, because no one had built the apparatus to look. When the collapse finally happened in 2006, the scale of the exposure became immediately visible. Safety inspections conducted after the accident identified 242 additional bolt fixtures throughout the I-90 connector tunnel that were also potentially dangerous, supporting ceiling tiles just like the one that had fallen. That number is the clearest evidence that the July 10th collapse was not an isolated defect in one panel. It was the first visible failure of a condition that existed, in some degree, across nearly a full 250,000 fixtures in that tunnel alone. The financial consequence of having no monitoring program for 3 years followed immediately. Repair and inspection of the affected tunnels cost $54 million in the first year alone. Sections of the tunnel were closed for repairs, with one segment shut for nearly a year. The cost of retrofitting after the fact, inspecting every one of those 242 fixtures, and correcting them, dwarfed whatever a sustained monitoring program would have cost in the years after 2003. The absence of ongoing inspection did not save money. It deferred a cost, and that deferred cost came back due with a human life attached to it. The human toll of this sequence of deferred testing and absent monitoring was borne by two people who had no part in any of the decisions that led to it. Milne Del Val was a passenger in a car passing through the I-90 connector tunnel just after 11 o'clock at night on July 10, 2006. She had no way of knowing that 5 anchor bolts had failed testing 7 years earlier, or that no monitoring program had been implemented in the 3 years since the tunnel opened. She was killed when the 26-ton ceiling panel came down on the vehicle. Angel Del Val, driving the car, survived, but was critically injured in the same instant. The gap between what the epoxy could hold long-term, 4,285 pounds per bolt, and what it was actually being asked to hold, close to 5,000 pounds per bolt, was an abstract engineering figure, until the moment it became the specific, physical cause of a death and a critical injury on a specific night, in a specific tunnel, to a specific family. The institutional response that followed unfolded over the following months, in the language of liability and litigation, rather than engineering. In November 2006, the Massachusetts Attorney General announced a civil suit seeking more than $150 million from 3 parties: Bechtel and Parsons Brinckerhoff as project manager, Modern Continental Construction as builder, and Powers Fasteners as the manufacturer of the epoxy adhesive at the center of the NTSB's findings. The framing of that suit, naming the designer, the builder, and the materials supplier together, reflects how the failure had already been understood by that point. Not as a single company's error, but as a breakdown distributed across the design, construction, and materials supply chain, each of which had a chance to catch the epoxy's inadequacy, and did not. For the Del Val family, the legal process eventually produced 2 distinct outcomes. Powers Fasteners agreed to pay $6 million directly to the family, separate from its other settlement obligations. That payment, arriving after a death caused by a materials failure the company's own product was found responsible for, stands as the most direct financial acknowledgement of the human cost among all the settlements reached. No dollar figure changes what happened inside that tunnel on July 10, 2006, but the specific direction of that $6 million, from manufacturer to family, marks where the financial and human consequences of the failure most directly intersect. The full financial reckoning for the Big Dig ceiling collapse extended well beyond the initial $150 million civil suit and the $54 million spent on first-year repairs. Total settlements across the litigation eventually exceeded $400 million, with 6 indictments issued as part of the legal aftermath. Powers Fasteners, the epoxy manufacturer whose product the NTSB had identified as lacking adequate long-term creep resistance, agreed to pay $16 million under a deferred prosecution agreement. A manslaughter charge against the company was dropped as part of that arrangement. That $16 million was separate from the $6 million the company paid directly to the Del Val family, meaning Powers Fasteners' total financial exposure from a single inadequate adhesive choice reached $22 million, not counting legal costs. 2 additional companies contributed to a forward-looking fund rather than a one-time settlement. Gannett Fleming, the ceilings designer, paid $1.5 million toward future tunnel maintenance. Sika Corp., another epoxy supplier connected to the case, paid $200,000 into that same maintenance trust fund. The creation of a dedicated maintenance trust, funded by parties found liable in the collapse, is itself a quiet acknowledgement of what had been missing in the years between 2003 and 2006. A funded, ongoing mechanism to monitor and maintain the tunnel's structural fixtures over time, the exact kind of program that modern Continental, Bechtel and Parsons Brinkerhoff, and the Massachusetts Turnpike Authority had all declined to establish before the collapse. When the full sequence is laid end to end, the pattern is one of cost and schedule priorities repeatedly overriding structural verification. In 1999, a failed test was not followed by further testing, a decision that avoided schedule delay and additional testing cost at the construction stage. In 2003, the tunnel opened without a monitoring program, a choice that avoided the ongoing cost of inspection infrastructure. Both decisions deferred cost rather than eliminated it. The bill came due in 2006. $54 million in first-year repairs, a tunnel segment closed for nearly a year, a $150 million civil suit, and ultimately over $400 million in total settlements. Measured purely in dollars, the eventual cost of the failure vastly exceeded whatever the further testing in 1999 or a monitoring program after 2003 would have required. Measured in human terms, the cost was Milna Del Val's death and Angel Del Val's critical injuries, outcomes no settlement figure was designed to reverse. The Big Dig ceiling collapse stands as a record of what happens when a known warning sign from a failed test is set aside, and when a structure is allowed to operate for years without anyone assigned to watch it change.